Good morning and thank you all for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor, Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will share my screen. Okay, so good morning, everyone. Hopefully, all of you are safe. You're doing well at home. Now, I will just quickly walk you through the agenda for the day. Okay, check this out. So today we are talking about Azure Synapse Analytics and how can we integrate Azure Synapse Analytics with our other Azure Data and AI services as such. Now, as part of this session, we will be taking one scenario of a customer and we will discuss it out. We'll think like we'll go through the problem statement. We'll understand the problem statement, then we'll design the solution, and then I have the implementation of that as well. Now, before I do that, I also want I just want to walk you through the post session link as well. So if you go to the meetup page and you click on the further learning link over there, it will take you to the learning path on MS Learn. Now over here, you will see that there are two modules which you can complete after the session today. And you just have to sign in from the top. And once you sign in, you will be able to save your progress as well on this page. So these two things we are also covering in the session. And then if you want to uh, reproduce the same demo or reproduce the same scenario, then you can go through these two modules here. So if I walk you through these two modules, we have the integration of Power BI with Synapse. How can we do that? What's the any details, any concepts around that? That's one of the module. And the second thing which we are covering is how can we do machine learning with Synapse? Now this machine learning is not the usual Spark based machine learning which we do with by importing any library over there. This is with or this is via Azure Machine Learning Service, the custom AI service which we have in Azure. So we'll see how can we do that. Now, okay, so now if I just show this to you, we have various modules here. We have the description of the services. We have like how can we create these services, how can we connect them, what is AutoML, and so on and so forth. You can click on these modules. And once you click on these modules, you will be able to find the screenshots and the implementation of it and so on and so forth over there. So I recommend that post this session, you can go through that MS Learn link over there and complete that learning path. And whatever we'll cover is covered over there in more structured and in a better manner as well over there, step by step, right? Okay, so let's get started. Now, the company name which or the customer name is Wide World Importers. And I have just taken one picture from internet over here. Now, we'll go through the problem statement and then we'll spend our time into the implementation after that. So if you have been joining me for the previous session, you might have remembered that we do a lot of whiteboarding, right? So we will do that same thing. So Wide World Importers, it's basically you can say it's a, they have, I have the problems, the summary of the problem statement over here. They have physical stores and they have online stores as well. And they would like to gain business insights using historical, real-time, and predictive analytics on structured and unstructured data sources. Now, uh, so they want to enable their IT team to IT team of data engineers and data scientists to bring in and run complex queries on petabytes of data of structured data with billions of rows and unstructured enterprise operational data. At the same time, they want to enable business analyst and the IT team to share that single source of truth and have a single workspace to collaborate and work on the data. Now, they want to accomplish this by minimizing the number of uh, heterogeneous services. As such, they also want to ingest, transform, query, store their data as such by minimizing the number of services. Also, minimizing them at the same time, they also want to minimize the number of services, and they want to have that single one-stop shop or that master tool that can be used for, which can provide all the best practices for development, management, and monitoring. Now, this is just a summary of the entire scenario of wide world importers. Now today we so it's a the problem statement is pretty big. So today is the time when we focus on the on one part of it where we integrate Azure Synapse with the other AI services and data services as such. So if I just quickly align you with my the whiteboard diagram over here, this is something which is going on. They are getting feeds from Twitter on which we have to do sentiment analysis. They are also getting the the traffic telemetry from the various physical stores which they have through the IoT hub. And then that single source of truth is this data lake over here. Now, what we are doing today is is this portion of the deployment, and I'll show you what we are performing over there as such. And just to summarize a couple of more things, we have to prepare the data, train the models, use the models. There are two main problem statements which we want to answer today or we want to understand today. Those two will be that it will be regarding sentiment analysis. How can we do that? What are the process? What is the steps? How can we do it securely and so on and so forth? Right. The second thing is they want to forecast the number of the quantity of the products. So they want to do that regression analysis. So two problem statements, sentiment analysis and regression needs to be done on the data. So sentiment analysis to find the sentiments of the customer who are tweeting right now on Twitter. So before something goes viral, they would definitely like us to provide them some sort of heads up that maybe their team can go and respond back on the tweet on Twitter if sentiments are negative, right? Something like that. Second thing is like forecasting the quantity of the product. So uh, they can put the appropriate products in the appropriate locations, or they can manage the number of quantities, or they can do the inventory management properly. So these two things we have to do today. Now, the solution looks something like this. This is what I have over here. I'll walk you through this, right? But I have, so we have 1 hour of session, right? So I actually have already created the diagram, so it doesn't take much time. Okay, so I'll just walk you through the things which I have deployed, and then I will just take you through this. So if I take you first to my Azure subscription and find my resource group, and I just want to show you that I have a couple of things which I have deployed here. Application Insights, Cognitive Services. So Application Insight is a monitoring service. This is Cognitive Services that's we are going to use that pre-built AI solution. That's ACR, the registry for Docker images. That's my data lake. That's one key vault where we will keep the keys. One machine learning workspace. So this is the machine learning service where we do custom AI solutions or custom ML. solutions. We design those models over there. This is one storage account. I don't think if we are using it. So that's the main uh, the Synapse workspace. This is just some extra things which are not related to our scenario. We have the Spark pool. Spark pool is the Spark cluster. That's this is the dedicated SQL pool. This is a warehouse over here. So one Spark cluster and one warehouse as well with us. Now, basically, if I take you back, so all those components are here. So the very first thing which we start is we start making things talk to each other. We want authentication and authorization to happen. So we start from somewhere from here, right? From this location. So we go to Active Directory, Azure AD, and in Azure Active Directory, we basically create some service principles over there. These service principles will be used for linking various services together. Like if Synapse Analytics wants to talk to another service, or if the machine learning studio wants to talk to another service, then how do they talk, right? How do they communicate with each other? Or how do they authenticate and authorize with each other? That's the main thing over there. So we want the service principal to help us out in that particular step. Now, with service principal, we do the auth flows over there, right? Authorization flows. So we have created the service principal and we have stored the secrets inside the key vault. See, the secrets needs to be stored somewhere, right? You cannot have it in some unsecure location. So the secure location is the Azure Key Vault, which is backed by hardware security module. So what I have done, if I take you back to uh, my Azure portal, and if I just arrange them in the order so I can just quickly flip between them. So I went to my Active Directory over here, and let me zoom in for everyone. Okay, so this is my directory. Okay, so this is my directory over here. I think it's too zoomed in for me also. Let me find my directory again. Okay, so this is my Active Directory. And over here, I have done this app registration, which is the representation of my application in this directory. And the name which I have given to this app registration is Azure Synapse Analytics lab. And that's my unique suffix over there. So if I click on this, this is the service principal which got created, or this is the app registration which will have the equivalent service principal representing my application in the Active Directory. It's a type of mechanism by which we tell Active Directory that later on the application will be coming for the token. Please give it the access token like that. So we do this, and this is what is being represented over there by that circle over there. That's the first thing which I have done. And then there were some secrets. See, we cannot hard code these secrets in the code, because if they got published in your code repositories, then that's something which you should always avoid, right? So what we have done, we have taken those secrets and we went to Key Vault. And in the Key Vault, we basically uh, so I clicked on this setting over here, and I created this secret and I copied the value which is saying hidden now, because it's hidden now as it says. But basically, if I went back and I kept that value inside my Key Vault. So Key Vault is the implementation of it's the software Key Vault which can be backed by hardware HSM. So I went to the secrets and I have created multiple secrets here. You will see that oh, not authorized to see this. Okay, one second. Let me uh, I think this is the demo account, and I will just open the other admin account, which will have the rights. This is also good. We have access policies in Key Vault, and if you don't have the access in the Key Vault, so just FYI, on this user, I have a global admin and subscription owner rights, but still that user cannot see the Key Vault secrets. So because of the access policy, which is great. But if I just go and show those things to you, so this account is totally dummy. So I don't have any issue in showing more details to you guys. So you see, we have all these secrets over here. So what we have done, we have kept some cognitive services secrets, which we'll be using in some time. This is the one which I was talking about, this one. And basically, I clicked on create before, and I uploaded the secret there over there. Now, if I so all those things are done. Now, if I take you back to my diagram, so the secrets are there in Key Vault. Key Vault is by default used in all the settings from this point onwards. And in all the settings, we are pulling the secrets from the key vault. Okay, now Azure Machine Learning Service is the service where we create the custom AI solution. So if I just walk you through this, you may have joined me for previous sessions, but if I just walk you through this service for the day, you will see this is the machine learning service where we have all the things on the left hand side: notebooks, AutoML, designer capabilities, dataset, experiments, pipelines, and so on and so forth. Model, endpoints, compute, data store, and other services are there. So we do the ML over here. So today we are using the AutoML of that, this one. So we don't have to. So it's type of AutoML basically is AutoML. It will do the hyperparameter tuning. It will check out various algorithms. This is what we will be using today. We'll understand how we are doing that. So what I have done, I have created this Azure Machine Learning workspace, and this Azure Machine Learning workspace has been connected to the Synapse Analytics over there using linked services. So I went to the manage option over here. I clicked on the linked service over here, and I clicked on the new linked service on the top, and then I searched for my machine learning workspace. And then using the keys, pulling the keys from the key vault, I was able to use that and connect both of them together. Now, okay, so this part has been done. So this is what that line suggests over here, that the connection has been done to the between the Synapse and the machine learning workspace. So secrets are here. This is the connection. They both are connected now. So two different services of Azure got connected to each other, right? Now, after that, we go mainly inside the Synapse. Now, in Synapse, we have a couple of things right now. We have one data lake there. So data lake is connected to it. It's also using one linked service too, as such. And data lake is the replacement of HDFS in Azure cloud, right? Or in all the clouds. The object stores are replacing the real HDFS locations in all the clouds, including Azure as well. So this is that data lake which is linked with the Synapse. This is where this is a single source of truth where all the data is going, and this is the one where we have three folders right now: staging, workspace, and wide world importers. So all the data, the streams, and the in the batch ingestion data is going in the ADLS as such in this point in time. So we are starting from that point onwards. So all the data is here, all the raw Parquet files, CSV, TSV, all the data is here. So what we do, we basically apart from the data lake, which is a type of storage location. So this is the storage location which has no limits over there, right? Where the entire data of wild world importers is getting centralized or collected. So apart from this, we also have created one Spark cluster there. Now, when we are working with big data services, Spark is one of the obvious choice as such, where we have the master and the worker architecture, and in Spark is also available inside Synapse. So the name of the service is Spark Pool. So it's a type of serverless service where when you trigger the job, then it gets created and executed more like a job-based cluster. So now I have this in place over there. My cluster is basically having two nodes and one driver, one master over here. And apart from that, two nodes are there. The diagram looks slightly bigger. Now, apart from so, okay, so this service is basically the big data service, which is going to or this is the big data compute service where we are going to run the jobs or the .NET Spark code or PySpark or Scala or Spark SQL jobs will be running over there. Now, the storage solution in Synapse or the warehousing solution in Synapse is called as dedicated SQL pool. So we are using this. Now, what I have done, this is how it looks like. This is the warehouse inside uh, inside Synapse. So what this warehouse does, it basically is having three different layers over there. Control node is there, compute nodes are there, and storage distributions are there. These storage distributions are basically premium blobs at the backend. So it's built on top of object storage. There are 60 premium blobs at the backend where data is distributed. So we are also using that. Now, this architecture is called as MPP architecture, where we are storing the historical data of wide world importers. That's the main location from where we want to do the ML today as well. Now, inside this inside this warehouse, we have various tables over there. I'll walk you through the tables now. I'll just walk you through the rest of the components of this architecture. Then we'll just zoom on and we'll go into the code part of it. So this is one of the component over here. We also have one. I have Power BI license right now, Pro license, and it's already connected with Synapse. So Power BI is also connected, and we will be able to see some dashboard there. Now, apart from this, uh, we see one of the pillar of good architecture, or one of the pillar of you can say well-designed solutions will be automation. If you can automate stuff, if you can eliminate the human part of the you can say uh, the steps over there, then that is basically something which is very recommended. So we are using the pipelines of Synapse. These pipelines can be used to create the ETL and the ELT jobs. Now we are copying some data. I'll walk you through that. And we are using stored procedures, and these stored procedures are lying inside the dedicated SQL pool. And those stored procedures are the ones which are actually pulling the model, the trained machine learning model, and doing the model.predict, this one over there. So, but that is automated by using the Synapse pipeline right over here. Now, apart from this, we are also using the cognitive services of Azure. Cognitive services are the pre-built AI solutions where the ready-made solutions are there, which you can use in various solutions to provide AI capabilities to your products. Now, okay, so let's get started with it, right? So what we did, this is what we have. So the data is there inside the storage account. This is literally a storage account which where we have enabled the data lake option. So inside this ADLS is where I have the data. Now what I did, I basically loaded the Parquet files. So we have the sales data, historical sales data. So we loaded the Parquet files inside the Spark pool over there. So if I take you back to my Synapse workspace, and if I click on the various scripts I may be having over there. So I just want to show you a couple of things over here. Now, okay, so this is a data lake which I was referring to in that point in time, and this is the one where we have all the data. So workspace, staging, and wide world importers. Three folders are there. Three containers are there, and inside this one we have the most of the data for the company. Data generator, small sales, small data set. The product quantity forecast folder is there, product reviews, states, telemetry, and so on and so forth. So we are using so data set which is there inside this. So year 2019, quarter 0 Q4, 12th month, and day wise we have the data which is segregated over there. So this is 01/12/2019. This is 02/12/2019, like that. So basically, this is the file which I have. It's a Parquet file which I have loaded over here. So it's not even like this Synapse is pretty low code type of solution. It has a lot of these type of functionalities. So you can simply do it like this. You can say load to a data frame like that, and they will fill up some of the boilerplate code for you, and you will be able to work with it over there. So this is what we have done over here, and I have this over here. Now what I have done over here is, after reading the Parquet files from the source. So we are saying spark.read, load the Parquet file from using the ABFS driver from this data lake. That's the container name, and the full path is here. Now we are loading the entire all the files from that particular directory. So we are using the star.parquet over there, the wildcard characters as such. Now the format is Parquet, and then we are doing a group by on top of it using the product ID, transaction date, R, and we are doing some aggregation on top of it. Now the output which we have, the consolidated output which we have, we are saving it. So we save it in we save it with this name. So save as a table. So if I show you that part, the table should be somewhere here. So the data has been pulled from the raw data lake, and now we have aggregated that data, and we are sort of we have grouped it by, we have done, you can say, a little bit of aggregation on top of it, and the table by on which we want to work is called as sales consolidated data. So this is what we have over here, that we loaded the Parquet file, and then we finally wrote that inside the warehouse over there. Now what I just so now on top of it, we want to do machine learning. So to do machine learning, uh, like typically, if you think about machine learning, you think about that. Okay, we have to maybe go to the machine learning service, create some compute cluster, then we have to connect that to the Synapse workspace, and then we may have to pull the data set over there and then work with it, like a lot of steps, but not really. So what they have done, you can simply sort of right click on this, and before this, your machine learning workspace should be connected. Like before that right click can be done, you have to come and you have to connect your machine learning workspace over here. And for this, there are some rights which needs to be given. So if you do the tutorial which we have provided in the as part of the post training link, you can definitely do that. So we have connected the workspace over here. And this workspace is basically, after this has been connected, I can do something like that. I can simply go back to my data and I can just say right click on it and I can say machine learning and then what am I looking for. So we have two options here, train a new model and predict with the model. So this train a new model is like train another new set. So this is what we have done. And this let us do the AutoML using the Azure Machine Learning workspace. You can see we have three options here: classification, regression, and time series forecasting. So I have clicked on the regression, and then I have selected my machine learning workspace, which is this service over there on the top, this one, which we have linked with the Synapse box over there, right? This one. So there's a workspace of Synapse, that's the machine learning workspace. So they both are connected right now. So now experiment name and all that, fill it up basically. Uh, and what's your target call? What's your target column? Like I have selected this and basically then given the okay, this is the interesting part. So we are doing the we are using the AutoML capabilities of Azure Machine Learning Workspace, but we are still training over the Spark cluster, which is in Synapse. So the good thing which I get by using the Spark pool over here is that uh, even when I'm working with big amount of data, I can just select the number of executors. I can use the Spark capability of doing things in parallel. Like if you have joined me for the previous sessions, you may have remembered that we were talking about the stages and the jobs, the job and the stages and the task assets, and the task inside the stage is running parallelly over in multiple executors over there. So this is the Spark executor which we have over here. And it's right now based on the size which I have selected. So it is showing me some upper limits over there. Otherwise, right, like this. This is my executor size, 4 core and 24 GB RAM, driver, and so on and so forth. So I have filled up this page over there. And once I did that, I have actually, this is where I have it in the diagram over here, that so this is the Spark pool. So we are using the Azure Machine Learning AutoML over there, and the logging will be done in the experiment section, but the trading is still is still going on through the Spark pool. So if you hopefully you if you work with let's say ML or with Spark, you may have realized that it's not something which is very, it is having a learning curve, right? You have to learn things, but you will see that here we were able to uh, anyone will be able to use this service with less amount of learning curve as such. They may have to understand few things, but it's pretty straightforward. Now, okay, so when that AutoML job was submitted, I selected couple of things that I want to do regression. The target is total quantity. So find the total quantity based on the historical sales data, forecast the future quantity which needs to be kept inside the stores, the inventory or the inventory which needs to be managed so that we can meet the you can say the number of the sales can meet the demand and so on and so forth, right? Now the compute is Spark type executor I have used two, and the exit criteria is 15 minutes. It's 1 hour of session only. I don't want it to run for a lot of time, so I have given one exit criteria that okay, whatever you do it in 15 minutes and just throw the output back. But if you don't put the exit criteria, what it basically does, the AutoML, is that it runs multiple algorithms of regression family, and it trains multiple models parallelly. So you can specify how many concurrent runs will be there. This concurrent runs also depends on the size of the Spark pool which you have over there. Now, we have selected two concurrent runs over there. So imagine two algorithms are getting trained at the same point in time. Hyperparameter tuning is going on, and whichever machine learning model is not performing will be eliminated. So imagine these are getting eliminated over there like that over a period of time. So by the end of it, we get the best model like that. Now for best model, you have to specify the criteria, like what are you looking for, reduce the error. In case of classification, maximize the accuracy over there. So whatever your criteria is, based on that criteria, AutoML will give you the best model. So if I go to my machine learning workspace now, and I show you what we have over there. So we okay, so this is the AutoML console. If I click on it, that's some default name. Now, okay, so if I click on the models, you will notice that there are multiple algorithms which got trained. So these are multiple algorithms on my data which got trained, and the best model is basically the first one over there, which I actually know because I saw this page before. So this is the best algorithm right now. Uh, it's an awesome ensemble model. Voting on ensemble is the algorithm, and this is the best model. Now I don't want to deploy it. That's not what I am looking for right now. But obviously you can deploy this as an API endpoint also, and you can work with it. Now what we are doing is we have registered this. So register this basically means like save it in the repository over here. This is the model registry, and this is the version 1 of it. And if we run the experiment many times, it will have various versions over there. Right now, 1 is the version, and some other properties are there like what was used at the backend for it to execute. We are using ONX, Open Neural Network Exchange, which basically will provide two things, very important two things in the machine learning world. One of the good features of ONX is that the model will become the saved model will become platform independent. We don't have to install, like let's say you train the model in TensorFlow or you train the model in PyTorch, and when you deploy it, so in that deployment location, the dependencies are not supposed to be installed if you convert it into ONX as such, Open Neural Network Exchange, and only ONX dependencies needs to be installed. So it makes it really sort of platform or you can say framework independent type of model. Secondly, inferencing also is faster. You will be able to score faster, and the increase in the score is somewhere from literally in one of my previous scenarios where I was doing the session with you guys. The score was it outperformed the pickle file. Uh, I think it was a TensorFlow model or PyTorch model, some sort of model was there which we were working on, and it outperformed by 255 times. Like 255 times, it was faster than the normal when you do the inferencing with the ONX model versus non-ONX. So this is something which we are using. It's amazing. Now some other details are there. Now what we have done, this is all good, right? The model is there in the registry. Now what we do, we would like to use this to do some scoring for us. The way in which we are doing it is we will go back to Synapse. We'll go back over here. We'll say that okay, uh, we'll select one table and we are creating one stored procedure right now. And what that stored procedure will do, when that stored procedure is executed, that stored procedure will pull the model from the machine learning workspace, the latest model, which I just showed it to you, and it will pull it from there and it will do model.predict, and the output will go in the in another column as such over there. So this is the step which I have done, and I will just show you that. So let me just go through. Yeah, okay. So this is the stored procedure which I have created over here, and it is doing that model.predict over here using that model. This is the name of my model. This is the ID of the model which I have trained. This is the one which is saved inside the AML studio over there. So, okay, now, okay, that's great. Now, how do I use it? I would like to sort of automate it. Like I don't want to run it manually. So then what we can do is we can click on this integrate option, and here you can create the pipelines as such. So this is one pipeline which I have created. What this pipeline does, it's a two-step pipeline. it basically runs. I haven't scheduled it yet. I just triggered it as such. But what we can do, we can schedule it, and so it runs on your the frequency which is suitable for you. Now, there are two steps in in this pipeline right now. So we call these as activities over here, these boxes over there. And this is the copy activity, and that's the stored procedure activity, which is going to execute after the copy activity. So what copy activity does, let's say it this is basically over here. What it does is it pulls the data from the data lake, like next time, like whenever it will run for the next time, it will pull the delta data from the data lake. Because if you remember, wide world importer is getting the data from streams and batches as well. So whatever delta data is there inside data lake, this copy activity will move that inside the tables which we have created. Now it is using Polybase over there. Polybase is one functionality or one utility, or it's a type of connector, or it's a type of solution by which we can import export data from the warehouse, the dedicated SQL pool. So that's what we are using, and this is also called a staged copy. This is a recommended method by which you move the data from data lake inside the warehouses. So it uses the Polybase functionality at the backend. So I have configured it in the settings. There is nothing which needed to not much needed to be done, but there were some tick marks which I have done it here. So it's a low code solution, and sometimes it's really no code, and sometimes you slightly have to put some code here and there. So, but that's not a type of limitation if you're thinking it through. We can totally enrich the pipelines with other programming languages, right? So now, uh, so basically, what I have done is the recursively copied from the data lake and go to the sync location, which is the warehouse. Use Polybase over there to write inside it. Now, uh, and there was some mapping needs to be done. A few new columns are coming up, so it was not okay. The columns were not here right now, but the mapping was. I imported the schema and did the mapping here. And in the settings, I have selected the staging location as my data lake, and the folder is staging folder over there. So it's called as a staged copy. This is a recommended method in which we push the data inside the uh, warehouse. Now, the second step is the stored procedure. So this is a stored procedure which we have created earlier, and we are just selecting that stored procedure over here in this step, and we would like this to run. So what the stored procedure does, this one pulls the model from the Azure Machine Learning workspace, and it does model.predict. So from here, it pulls the new model, the latest model, the registered latest model, and does model.predict. And the output goes into the same product quantity table. There is another column which is there, which where the output goes over there. So that's one thing which has been configured, and I should be able to show you that. Okay, so this is the forecasted quantity, the the forecasted quantity over there, this one, like this over here, this one. Now, so this is one part of the solution which we did. The second part is the sentiment analysis. Like, this is a regression analysis which has done. So how do you do sentiment analysis? So two methods: either make your custom AI solution, or use the best solution called as Cognitive Services, which are type of SOTA models which are there, and they are as good as they can be. So we are actually using that, and the I have two cognitive services. Okay, I think let me just quickly find the one which I have finally used. So I created the cognitive services first, and cognitive services are pre-built AI solutions. So yeah, I think that's the one which I created. So now uh, these are hosted, they are made by Microsoft as such. You can use them over API calls. You can also run the models locally. Like, you can export these solutions of cognitive services. Now, so the one which we are using is called as text analytics. That's what we are using. I have just taken the key and I have kept the key inside the key vault. So I don't have to hard code it inside the code. So that's one thing which I have done over there. And then I simply went back and I have another file which is coming from Twitter. So there is a feed which is coming from Twitter, which we basically have inside the wide world importers directory over here. And that is what we are loading in. That's the product review.csv file. We'll find it over there. And then on top of it is where we are doing the model.predict as such. So if I find that particular file in my data lake, so this is the feed which is coming from Twitter. I think product reviews over here, this one. Yeah, and that one. So now you can visualize it as well. So let's visualize, let's look at it first. Now, while we see now to visualize your data, you don't need Spark or you don't need any other tool. We have the built-in functionality. This is called a serverless SQL pool. So what it does, it let you run the queries on the raw data inside your warehouse, inside your data lake without the need of any Spark cluster over there as such. Now, the doesn't or used by another process. Okay, so now basically, uh, what I have done is I have executed all of this, and I will just find the process which is still using it. Okay, now after that, uh, let me just show that part to you. Okay, so this is the process which I used it before. So that's we are loading that CSV file. We are saving the table as product review. Then we use the cognitive services over there to work with it. Now this piece of code is not written by me, it's auto-generated. So if I show you how it can be done, so any analyst can simply go to the data, can find the correct table first, and then click on machine learning and say predict with a model. So you will see that we have various pre-trained model which are there, like anomaly detection models and sentiment analysis. And then click on new, continue, and then select the language on that's the language of the tweet as such. English and other languages are also there apart from that. And then you will select the cognitive service which you have created earlier. So something like that, and the target column. So like review the text as such. Now, once you do this, you will be able to execute this particular, uh, you can say you will be able to enrich your data with cognitive service. So so what this sentiment analysis inside the cognitive service called as text analytics, it basically will give you the sentiment, like is it the tweet is positive or negative, or what is the you can say what is the how negative is it? Like it will give you the score between 0 and 1. Is it like neutral or bad or pretty bad and all that? So you can, from the score, you can understand how negative or how positive the tweet is. Now, the output of it, basically, once we do that, the output also needs to be stored somewhere. So we have already done that. We have stored it, and the output goes uh, in the product review table. So let me see. We may have to execute the last part again. Oh, I haven't saved it yet. So the yeah, okay, great. Luckily, I published the workspace, so the outputs are still over there. Uh, Now you will see that this was the text over here, and let's read one of them randomly, right? So the product was larger in size than the advertisement, and it seems uncomfortable to use. Okay, uh, they don't like it. Great. So the product was perfect. It seems to be working well. They love it, and great product handles well. They like it. They don't like it. And they're unimpressed with it. Someone is happy with it. This is the dummy data. So what cognitive service has done, it it has basically extracted the sentiments from it, like positive, negative, and so on and so forth, and then how and what's the score of it, like how negative, how positive. So like the confidence score, like what it thinks, what the cognitive service think is this statement to be like, it is saying that okay, the because see the statement that in the tweet body you can write multiple statements as such. So it's possible that there is somewhat positivity in one of the statement over there, and other things are totally negative, like that. Let's say if we think it through, let's say the food was great but the service was bad, right? So the feedback to the restaurant will be that the service was bad, take care of the service, and the food was great. So those type of things it does. So it's telling us the sentiment, the sentence wise sentiment as well, like uh, that first sentence was positive, 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 like that, or maybe positive, negative. So you will be able to identify the main feedback of the customer from the entire dump or the entire utterance of the customer over there. So this is how we can do the cognitive, we can utilize the cognitive service to which we can utilize it directly from the Synapse workspace, and it will be able to, uh, anyone can do it, sort of nearly, right? The learning curve will be reduced, so we don't have to write so much of boilerplate code, and everything is pre-created, pre-generated, like that. And rest, we definitely have to update things when things doesn't work out. Now, this is what I have for the session today. So what we were able to do, we were able to connect the machine learning service with Synapse. We understood that we have the capability of loading the data from ADLS into Spark, Spark into the pool over there, uh, as such, and then load it back if required. Create stored procedures. Stored procedures can be automated with the pipelines, uh, and the entire thing can be secured using the uh, the key vault, and Active Directory is the one which can be used for authentication authorization. So this is the problem statement of wide world importers. And now, post the session, I will recommend you to, if you are interested in this, you can simply find the link from the meetup page, and you can complete these modules over there. And just want to show you the Power BI part. I already have configured it. I didn't show that to you, but I was able to connect this. I went to the managed service and did one connection with Power BI. And then I purchased I went for the trial license of Power BI. You can also do it because as such. And now then created one workspace and pushed the let me find my workspace, this one. And one of them is the report, which I just generated. So this here the report should get loaded. So this is just showing the forecasted quantity which we need in future versus the ID of the product, and we can also have it with the date and all that. So that's Power BI. And one last thing, that it can also be integrated inside the Synapse workspace. So if I just come back and if I click here, if it is properly integrated, it will be visible over here. So your Power BI is also, you can modify the reports, you can edit the reports, you can uh, you can make it look better over here, and then simply publish from here, and it will be published over the website uh, as such. So if you, I'm pretty sure you are aware that uh, the Power BI is also can be published as websites, right? Or you can embed that in other solutions. So this is, uh, you can generate the link, and so you can publish from here, and then things can accordingly work, or update the dashboard in the same pipeline also, right? When the data is moved, then how do you work with it? So this is what I have for this session. Sorry, and if I'll just go through the questions, and you can also unmute and ask your questions as well. Okay, so in the meantime, I just do that. I'll keep I'll keep the page open for you to go through that. Okay, so I don't think if we have any questions right now. So if anybody want to ask anything, you can unmute and you can ask as well. So let us know your questions.
Or
Hello,
if you
Shivam.
have any,
Hey,
Yeah,
hi.
one
Yeah.
question. Yeah. What are the advantage of the if you use Synapse Analytics?
Okay. Now the advantage of Synapse Analytics will be okay. So think of a customer who is think of two customers. One customer is looking for only let's say Spark functionalities, or is only looking for uh, let's say ETL and ELT functionality, only that. And there is another customer who is looking for the tool which can take care of the entire analytical suite or analytical stack. So what Synapse does, Synapse provide that unified dashboard, unified service, or that one service which has four capabilities. It will have the Spark over there. It will have the warehousing capability. It also has the pipelining capabilities, and it also contains EDA capabilities. The so I can explore my data. So it's a one-stop shop. It's like one single tool which can do all of that. So now my data scientists and my data engineers and data analysts who are working on the Power BI reports, they can be managed from, or they can be given access to this central tool. One of them will make the table, one will do the enrichment of the data, one will create the Power BI dashboard, and all the management is from one tool. I don't have to connect multiple heterogeneous services together. If I use Synapse, I don't have to think about authentication between heterogeneous services. If I use Synapse, I can do the RBAC, or we can do the user management over here inside this one single tool. So it's a type of analytical suite. It's a suite of product which caters to all the requirements of any customer, like that analytical requirements of the customer. So this, and it is as good uh, as such. So this is the capability, or this is where we put Synapse versus other heterogeneous tools where they don't have all the capabilities. They do one thing, but we have this one tool which combines all of them together and provide you that one-stop shop. Right? Okay. Any other question? Think it through. Okay, so I have another session in the evening also, so please do join me for that. That's a totally different session. It's on uh, PyTorch for audio classification. We will do more hardcore machine learning, and please join us on the Reactor LinkedIn page, and you will not miss any updates over there. And we do so we are involved with all the different. We cater all the different type of audience. So some of the sessions which we do are for the advanced audience. Some of them are for the beginners and for intermediate audience as well. So we try to cover the entire stack. So please do find the previous recorded sessions on YouTube as well, where I have talked about various other components or various other services of Azure. And please do find us for the upcoming sessions as well.
thank you, Shivam, for the session, and thank you all for joining us today. Uh, like Shivam said, you can always reach out to him later also if you have any further questions. Also, please do share your feedback about today's session and use the Learn module link for your further learning. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again, and see you at 4 p.m. today for the next session. Thank you.
Thanks everyone. Thank you, Rashmita. Have a nice day.